Robot Talk is the podcast that sits down with robot enthusiasts from around the world and asks them the questions you always wanted answered. Like, can that robot feel what it touches? And how does that thing work? Hello everyone, welcome to Robot Talk. I'm your host, Claire Asher, and this week I'm finding out more about the latest advances in sensor technology that are bringing robots closer to feeling the world around them like we do. Before we get started, I'd like to remind you that you can send in questions for my future guests. And there are a few different ways you can do that. You can submit questions on the website at robottalk.org or on Patreon at patreon.com/Claire Asher. Or you can contact me on social media at Robot Talk Pod. So, without further ado, let's get on with this week's interview. I recently had a really interesting conversation with Anuradha Ranasinghe from Liverpool Hope University about haptic sensors for wearable tech and robotics. This week, I'm talking to Anuradha Ranasinghe, a senior lecturer in robotics at Liverpool Hope University, researching haptics, miniaturized sensors, and perception. Hi Anu, great to have you on the podcast.
Hi Clara, thanks for having me.
So, gamers in the audience may be familiar with the concept of haptics as the way that their game controller gives them feedback through vibrations. But to introduce the topic, can you briefly explain what we mean by haptics and how it relates to robotics?
Sure. So, haptic means actually sense of touch. Like just imagine, if you can have a robot can detect the pressure or a force or the texture of an object, that would be excellent. So in robotics, this is quite important because if we use a robot for exploration or manipulation, things like that, if we can detect or extract haptic informations and provide some haptic feedback, that would be excellent. So in general, just imagine, like maybe in the morning we woke up and but we didn't open our eyes, trying to reach to our mobile phone or the glasses or the book that we read last night, something like that. So if we did not open our eyes, so we're trying to, explore the object, maybe it's your phone. So how do you distinguish your phone and the book? It's just you explore the texture by using your hand. So in that case, you are using the fingertips. So you are trying to understand the texture of the object. So that's actually haptic feedback. So in that particular example, we are not using vision, we rely on haptic feedback. Similarly, how do we use this exact scenario in robotics? So this is where haptics is quite important in robotics.
Yeah. And I guess I've kind of come across haptics in two different ways in robotics. So you've got kind of where you're talking about teleoperation, where you're remotely controlling a robot. Maybe that is giving you haptic feedback so that you can kind of almost feel what the robot is feeling or, get some sensory feedback. And then obviously the other side of it is kind of giving a robot the sense of touch and allowing it to experience the world. And I guess they're two different but both seem quite important areas of research.
Yeah. As you said, that's absolutely right, that you focused on two things. One is, sensing. So sensing means, like how a machine uses sensors to detect maybe a pressure or vibration or force, things like that in touching. And at the same time, so how we use feedback to maybe simulate that environment using vibration or forces, things like that. So both are quite important, especially if we think about remote sensing and monitoring. This is exactly where I'm interested. How do we use haptic feedback? Like simulate that environment, like how to simulate the force or vibration from a distance.
Yeah. So your current research is focused on developing haptic-based sensors. So can you talk about some of the biggest challenges that need to be overcome in this area of research?
Actually, it's quite a lot of challenges. So one of the challenges I would say, like how to find the right material.
Okay.
So, for example, if you think about remote sensing and monitoring, we can take quite a lot of examples. It could be search and rescue, or it could be, like some environment like hazardous environment, or some toxic environment like emergency of nuclear plant or something. So depending on the immediate environment, it can be a completely different environment that we interact in our day-to-day life in general. So in that case, what we need to think about when robots interact with something, maybe it can be an object, we need to think about what sort of material that we are talking about, like using in different applications. So at the same time, if you think about medical applications like robotic surgeries, things like that, it's again really, really uncertain environment. So we are talking about how to use some sensors, haptic-based, and adapt to a different environment. So I think that's one of the major challenges. And at the same time, since I'm talking about remote sensing and monitoring, things like that, and the other thing is the communication. So the latency can make a huge error. If you think about medical robotics, for example, if there is a tiny delay, it can make a huge difference.
Yeah. Absolutely.
So, I think that the communication, the material, there are so many challenges. So, just to mention those two are really, really challenging.
Focusing on the material aspect, like we take for granted how amazing our own sense of touch is, and the human skin, and the sort of the density of neurons in your fingertips is incredible. I guess that we're probably quite a long way from being able to replicate anything like that with robots. But maybe you could talk a little bit about where we're at right now, what the state of the art at the moment is.
Right. So I think completely replicate humans, it's really challenging, because I'm not sure whether we 100% understand this complicated human body yet.
Yeah.
So because we have quite a lot of systems and so many sensors and so many actuators involved to deliver different tasks in human, day-to-day activities. So how we interact with the immediate environment is really matters.
Yeah.
So when it comes to robotics, actually, so we have came a long journey at the moment, especially in computer vision. So computer vision has been integrated in robotics quite a lot, and it's evolving really fast, especially when it comes to, like text, images, videos, things like that. We know that our phone can recognize our face now. Similarly, there are a lot of advancement in computer vision.
Yeah.
But if you think about humans, so we basically rely on 5 senses like vision, hearing, touch, and the taste and the smell.
Yeah.
So those are 5 things like we rely on. And then as humans, we work as a multimodal perception model. So robotics actually at the moment is quite advanced in computer vision if we compare about, last 2 decades.
Yeah.
And haptics also evolving now. And then we need to, work on audition. There are research going on audition. However, we need to integrate them really well, like multimodal perception. So, and at some point, smell and taste, things like that, other sensory modalities.
Yeah.
So, I would say at the moment, the computer vision is moving really fast, and at the same time, haptics is integrated with that in some aspects.
Yeah, that's such an interesting point, because we don't experience the world as individual senses. It's all kind of one world that we create through the combination.
Yeah.
So you mentioned a few different application areas already. You've mentioned medicine, nuclear robotics.
I mentioned search and rescue.
Yeah. Would you say those are the main application areas you're working on? Are there others?
Yeah, those are the main areas actually I'm working on. I started off with, search and rescue and disaster situations like indoor firefighting, how to use haptics in those sort of situations. This is where I started.
Okay.
More than 10 years back in London. So at the moment, or in the recent years, I'm more focused on haptic-based sensors and also actuators, because I'm quite interested in remote sensing and monitoring. So when we have a sensor, how do you really, use this information from a remote location? And then if we have this technology, so we have to have something like maybe wearable to feel it. So maybe it can be vibration, it can be force feedback. So this is where I'm working on, how to develop an actuator also. So because most of the actuators these days, hydraulic or pneumatic, so they are quite bulky because of the technology, because pneumatic or the hydraulic, they are quite, bulky.
Right.
So that's where actually I'm really interested. So how do we get rid of this bulk actuators, like, something like a glove or a belt, wrist belt or something like that. For example, just after pandemic, NHS introduced something called virtual wards. That means the medical expertise can examine their patients remotely.
Okay.
So what they introduced was actually they provided a kit to the patient. The kit contained things like to measure some parameters, that like daily monitoring parameters, and at the same time a tab, to make a video call, for example. But of course, they can see the patient and understand the patient, the way the patient speak, things like that, and the patient can, record like daily monitoring, whatever they ask to do. However, let's say that there is a bump or lump on the skin of the patient. So how do they examine? They can see. However, so what if they would like to examine, like maybe touching, when we have face-to-face, appointment with the medical expertise, if there is anything unusual, they can touch and they can feel things like that. So what if instead of this like 2D images or 2D videos, but if they have like 3D images, like same as medical examination, things like that.
Yeah, that would be incredible. So one project that you've worked on is a sensor that mimics the human reflex reaction that we experience when we kind of automatically pull our hand away from something hot. So can you talk a little bit about that project and how the sensor works?
Sure. Actually, I have to give you a little introduction about the project a little bit. So this project, actually, I started 3-4 years ago. So it was again integration of haptics and vision together. So there was a sensor developed by MIT, 2009 actually. They started it. It's called gel side sensor. So this sensor actually can mimic the vision and tactile images, which is excellent because in the past vision was a separate thing and the tactile was a separate form. And again, in tactile, the force and the pressure, we measured everything like separately using different sensors. So they used actually very smart approach. So what they did was they used a silicon material, because silicon is flexible. It is, flexible means it's a deformable. So it's deformable, it has some elastic properties. In that case, if we use that sort of material for exploration, we can understand the texture of the object, not just the pressure point or not just the force, just like the texture of the images. At the same time, they used a camera. So there is a camera looking at the deformation of the silicon material. The camera can, extract the images, and at the same time, the material, the deformable material, can mimic what sort of deformation going, leftward movement, rightward movement, things like that. So I was obsessed with that sensor, to be honest with you.
Yeah, it's really cool.
yeah. And we replicated in our lab. And then, so at that point, actually, they used a bit of algorithm to detect, this deformation by using a dot pattern. So just imagine that you have a material, like a square type material, and you put some little bit of dot. Okay, and the material has some deformation properties, like if you make some such movement, you will be able to see how much each dot, change. In real time applications. However, if you use the same sensor for image classification or image recognition, those permanent dots are obstruct. So for that reason, actually, we came up with an idea. But once we developed the sensor, we said, okay, this is really permanent dots. What if we use UV light and UV markers? So if we use, UV markers as a permanent dot, because whenever we don't need it, we don't need to use it. So what we did was, since it is image processing anyway, we have to use light to process the images coming through the camera in real time. So we use like white light, RGB, and UV light all together. And in that case, actually, whenever we are interested in, understanding haptic images coming from the sensor, we can turn on the UV light. And if not, there is no permanent markers at all. We can use the same sensor for image classification and maybe recognition. So to answer your question, on top of that, so I had to tell the story a little bit.
Yeah.
On top of that, we introduced temperature-sensitive thermopigments or thermosensitive pigments. So the reason was like to give a clear picture about haptic perception. So if we can find the vibration or the force or temperature all together as an integrated system, same as humans, and then we can tell more about haptic feedback. So we tried, actually it was just a test and it worked. So we managed to find thermosensitive pigments and we did all the testing, and we managed to use these thermosensitive pigments to demonstrate the idea of 31 to 50 Celsius range temperature monitoring. So actually, surprisingly, when we do testing, we found out the response time of that particular material actually 443 milliseconds, which is higher than, like withdrawal reflex responses. So the idea is that, let's say that we are using a sensor for any sort of remote sensoring and monitoring. If it is anything hot than our threshold, it can withdraw by itself because it can detect that temperature that fast, like 443 millisecond response time. So it can withdraw by itself. So that's the idea.
Yeah, really cool. So the temperature sensitivity is determined by the thermal pigment you used. Is that right?
Yes, that's true. That's true.
Okay. So I guess if you wanted to do a different temperature range, you'd have to find a different thermal pigment.
Yeah, in our case, we managed only 31 to 50 range. So that was the only temperature we managed so far. But if we can go higher temperatures, as you said, or expand the range, that would be excellent, like maybe in certain rescue or disaster situations like that. Yeah, that would be excellent,
Yeah, I mean, 30 to 50 is quite relevant for a lot of, things that are important to humans.
Exactly, yeah.
I think this touches on a really interesting point that what we call touch is kind of an awful lot of different things, right? Like you said, it's pressure, it's texture, it's temperature. It's it's much more complicated than we give it credit for.
Yeah, it is very complicated, to be honest. Though actually, as humans, we take everything for granted, I would say, because there are so many informations we get via the skin, right?
Definitely.
So, and our whole body is covered by our skin. So we get quite a lot of information via these haptics, and we rely on that because since we use vision quite a lot or audition, so to rely or navigate things in our day-to-day chaotic environment, like uncertain environment, we normally don't think about haptics. However, we rely on haptics quite a lot than we expected.
Yeah. And so I know that one kind of goal you're working towards ultimately is miniaturizing these haptic sensors. Do you envisage that would allow you to have a really high density of sensors like I have on my hand, to kind of get us closer to what a human hand can do? Or how do you hope that you might use those sensors if you achieve this goal?
Well, it's a tricky question, to be honest with you. However, I'm not sure whether we can achieve as the same as a human.
Yeah.
Because, as I mentioned earlier, I'm not sure whether we understood 100% of how humans work.
Yeah.
However, there are some applications I can see if we can miniaturize. For example, if it is colonoscopy or something, or minimal invasive surgeries, things like that. So if we can have a miniaturized version of haptic or vision-based sensors, which we call visual-tactile sensors, in that case, actually, we would be able to get some subtle informations. That means we would get, haptic feedback, of course, like force, vibrations, things like that. Not only that, if the vision involved, we can get some, subtle information about tissues of the human inside. And at the same time, if we can integrate audition on top of that, we would get some subtle noises, things like we haven't, explored yet. So, this is one example. So I think it would be very important. We need to focus on developing those things, and at the same time not to forget about how we integrate other modalities like multimodal perception.
Yeah. So looking to the future, where do you hope new advances in sensory technology might take the field of robotics?
I think, as I mentioned a couple of times, multimodal sensory modalities, I think the future would be if we introduce more perception, like multimodal, like audition, vision. Maybe in the future, I don't know, like maybe smell, taste, things like that even would, we can enhance things if we introduce more modalities. So I think that could be the future. And at the same time, how everything works in a spatial computing using AI and other stuff. So I think that's going to be the future anyway. Yeah.
Mm-hmm. Yeah, really exciting field of research. I hope that robots will start to have a richer experience of the world with developments like these.
Yeah.
Anu, it's been lovely chatting to you today. I've been speaking to Anuradha Ranasinghe from Liverpool Hope University. Thank you.
Thanks so much for having me.
Thanks for listening. If you enjoy Robot Talk, I'd really appreciate it if you could share the podcast, subscribe, and leave a review. It really helps boost the podcast, so thanks in advance. And don't forget to join the Robot Talk community on Patreon if you'd like to support the podcast and get access to some awesome perks, including behind-the-scenes updates and monthly bonus episodes. Visit patreon.com/Claire Asher to find out more. Next week, I'm chatting to Daniel Nicholson from MakerForge about building robots at home. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk is brought to you by the Hamlin Centre, Imperial College London.